Hello, my name is Colin Scott. I'm with OneBridge Solutions. In today's video, we're going to be talking about the Cognitive Integrity Management Software Platform, or SIM as we call it with OneBridge. Now, those of you that are familiar with the SIM platform will know that SIM is able to pull in various disparate data sets and align them all seamlessly and easily. Now, what we do whenever we pull data into the system is we want to do data quality checks to make sure that the ingestion process has been performed correctly, and we want to make sure that all the numbers are lined up properly before we jump into the serious analysis. So what I'm going to show you today is some of the tools that we have at our disposal within the SIM platform that helps us do just that. So here I'm going to jump into the SIM platform, which some of you may well have seen before. In this case, I'm on the reports page and I'm looking at the preview reports. The one we're interested in today is the Weld Alignment report down here. This is a report that's still in the preview stage. It's just been developed and we're looking to get customer input on whether they like it or not. I think it's pretty powerful from our perspective. So I've already loaded up one of our demo systems. And the first page that we're going to look at is the joint by assessment page. In this particular case, we've got 4 different tool runs on our demonstration pipeline. The demonstration pipeline is the Salmon to Grangeville 10-inch pipeline. And in this case, we've got 4 inspection tool runs, one in 2005, one in 2010, and then 2 separate inspections in 2018. The first thing that we can see here is that there's a different number of joints that was reported by each one of the tools. So in the very first tool run, we have 645 joints reported. In the second tool run, 648, and then we have 649. So there's a discrepancy that we really want to look into. So what we do is we go to the second page of the report, which is called the Weld Alignment sheet. This one's an interesting one. Essentially what this does is it takes each one of the girth welds that's reported by the 4 tools and it lines them up against itself, against each other, and against the odometer. And what we can do is we can look at these various numbers in order to quality check the ingestion program, and we can quality check the numbers that we're getting in. We always want to make sure that our numbers are good before we jump into a serious analysis. Now, you'll see here that our cells are colored either blue or in red. The blue cells represent situations where we have 4 different tool runs that have all reported the same girth weld locations and the same girth weld lengths. So we're pretty happy with those. But you will see some red cells here too. The red cells represent situations where there's a discrepancy in the 4 tool runs, and there can be several reasons for that. One of them is, depending on how the inspection tool run was set up at the very start of the run, there will be some slight differences in length there. But as we get into the main tool run, we should expect all of our joints to line up. You'll see that as we scroll through our listing here, we'll occasionally come across some more red. And this really represents a situation where there are discrepancies in the various inspection tool runs, and we really want to rationalize why that would happen before moving on with our analyses. We want to make sure that all of our data is lined up appropriately. If we scroll down to, say, the 7,000 foot distance, we'll see something very clear and obvious that helps us understand what's going on. You'll see over here on the left-hand side, we have these red cells that represent a discrepancy between the tool runs. Here we have a 2005, a 2010 tool run, and then the 2018 tool runs. Now you'll see with the earlier tool runs, if we look right here at the joint length, we have a 44-foot joint length. And that's in 2010. But when we get to 2018, we don't have a 44-foot length. We have an 8-foot length, an 11-foot length, and a 23-foot length. And that's a really, really big clue that we've actually had a cutout and repair within that section of pipeline between 2010 and 2018. So that's really useful information to help us cross-check what's going on. Now, to do a further study, we'll go to our joint length by log distance plot. And this is exactly what it sounds like. On the y-axis, we have joint lengths, and typically in the 40-foot range. And on the x-axis, we have a log of distance or odometer. Now, what you'll see here is there's a big discrepancy between our 2005 and 2010 reported joint lengths and our 2018 reported joint lengths. So looking at a discrepancy like this is really a big a big pointer that there's been a cutout here. So if we're in a situation where we want to cross-check this, we can either look at our construction records if we have them and cross-check that there was a cutout and repair done at that location. But there are going to be some situations where a pipeline operator does not have complete records because they may well have inherited that pipeline from another from a trade, and they might not have complete records. So this really allows pipeline owners to really cross-check what's going on within their pipeline and make sure that they've got complete information before moving forward with the analysis. So hopefully these make sense. It's really just some simple cross-checks that we do on the data quality before moving forward with our analyses. SIM is a software platform that has enormously powerful capabilities in doing assessments, but that's really only valuable if you know that your data is aligned properly. And so that's what we're doing here.